Bismillahirrahmanirrahim. In this lecture, we have to explain second derivative test uh, for relative maxima and relative minima of a function. So, what is second derivative test for a functions? Second derivative test. Let f be a function such that f dash of c is equal to 0 and second derivative of f exists on open interval containing C. Let's suppose open interval is AB and C belong to this open interval. If first derivative at C greater than 0 means if second derivative at critical point greater than 0, then f of C is relative minima. If second derivative at a point C means if second derivative at critical point less than 0, then f of c is relative maxima of the given functions. Thirdly, if second derivative at a point c is equal to 0, then second derivative test will be failed. In this case, we have to use first derivative test. For example, if we consider function f of x is equal to f of x is equal to x square, then by first derivative f dash of x is equal to 2x. Now if we put f dash of x is equal to 0, which implies that x is equal to 0, means x is equal to 0 is a critical point. Now by second derivative of the given function, second derivative of the given function is equal to 2 is equal to 2. Now if we substitute 0 in this second derivative, this is equal to 2. Means second derivative at x equal to 0 greater than 0. So x is equal to 0 is relative minima of the given function. For example, if we draw function f of x is equal to x square, but x is equal to x square, and the graph will be like this. So x is equal to 0 or f of 0 is relative minima of the given function. Now we want to discuss further practice problem. Statement of this problem is use second derivative test to find extrema of f of x is equal to 3x power 5 minus 5x power 3. Now By taking derivative of this function, 3x power 5 become 15x power 4 and minus 5x power 3 becomes by power rule minus 15x power 2. Now if we put this function is equal to 0, this will be equal to 15x power 4 minus 15x square is equal to 0. Now by taking uh, term 15x square as a common, this will be equal to 15 x square into x square minus 1 is equal to 0. Now by solving this equation, we get critical point 0, minus 1 and 1. So this is 3 critical points. Now by taking second derivative of this function, 15x power 4 become 60x power 3 by using power rules, and minus 15x power 2 become minus 30x. Now if we substitute first critical point x is equal to 0 and this second derivative, we get f double dash of 0 is equal to 0. So in this case, test is failed. Test is inconclusive. Now if we substitute second critical point x is equal to minus 1 in the second derivative f dash of x, we get minus 30. Clearly minus 30 is less than 0, so f has maxima at x equal to minus 1. Now if we substitute third critical point x is equal to 1 in the second derivative, we get 30. Clearly 30 greater than 0, so f has a minima at x is equal to 1. So the given function has relative maxima at x is equal to minus 1 and relative minima at x is equal to 1, and test test is failed at x equal to 0. Now second example or third example, find the relative extrema using second derivative test of the function f of x is equal to x power 4 minus 4x power 3 plus 1. Now by taking first derivative, uh, x power 4 become 4x power 3 by using power rule. Term 4x power 3 becomes minus 12x power 2 and 1 is constant, therefore the derivative of 1 will be equal to 0. Now by taking 4x square common, this becomes 4x square into x minus 3. Now if we put first derivative is equal to 0, then by solving we get x is equal to 0 and x is equal to 3 is a critical point. Now by differentiate this function again, 4x power 3 becomes 12x power 2 and minus 12x power 2 becomes minus 24x. Now if we substitute x is equal to 0 in the second derivative, we get f double dash is equal to 0 at x equal to 0. So this means that test fails. Now if we substitute x is equal to 3 in the second derivatives, by simple simplification, we get that f double dash our second derivative at x is equal to at x3 greater than 0. So at x is equal to 3, the function will be relative minima. And the relative minima will be 3 minus 26. Now if we uh, check first derivative near to x equal to 0, left side and to right side at x equal to 0. So from an interval minus infinity to 0 and then 0 to 3. Now uh, if we choose minus 1 is a test point from this interval and 1 is a test point from this interval, then clearly that slope in these both interval is less than 0. So in these two interval, the function is decreasing. So at x equal to 0, the function is neither increasing and nor decreasing. Means at x equal to 0, the function is neither relative maxima and neither relative minima. So 0, 1 is neither a relative maxima or neither a relative minima of the given function f of x is equal to x power 4 minus 4x power 3 plus 1. Thank you so much for watching this video. Please subscribe the channel for more informative videos.